In this video, I'm going to present a solution to Workshop 2, which is the first application workshop in the BU Bioinformatics Programming Workshop series. Now, I'm going to assume that you were able to download the files just fine. It's pretty simple, wget in this URL. So I'm going to start by talking about downsampling this FASTQ file. Now, the way that I approached this was to simply use Unix commands to output the top 100,000 reads from a FASTQ file. So I'm going to just use one of these FASTQ files as an example. So I'm going to say zcat dc05 2al. Yep. And then I'm going to pipe that to head just so I can see the top, and this is in fact a FASTQ file. And recall that a FASTQ file has 4 lines per read. And so really what we want, if we want to get the top 100,000 reads, we want the first 400,000 lines of this file. And so I can look at take just the top 400,000 lines of this file. And since I want to compress this right back into a gzipped file, I'm going to pipe the output of head to gzip. I can provide the -c command line argument to make gzip print the compressed output to the command line or to the terminal. Now, I don't want to actually print out the gzipped output because it's in binary format and it would look like garbage. But I can redirect that output to a file using this redirect to a new file, 517.2al.100k.fastq.gz. Press enter. There we go, that was pretty quick. And now just to verify that we got the right number of lines, we can say zcat dc05 to al100k, and just pipe that to word count -l, and this will tell us that there are in fact 400,000 lines in this file. Just look at the top, and that's what we're working with. So that was how to downsample a FASTQ file to create another file that has many fewer reads. Now, the second task in the workshop was to parse this FASTQ file and identify good reads by the as those that end with CACA. Now, I wrote one big Python script to do this whole workshop, so I'm just going to go through them one by one. So the first thing that I'll say is that I imported a lot of modules from the standard Python library. And there are lots of modules in the standard Python library that are helpful both for writing code faster and making code that is more readable. And I'll go over each of these that I use as I go through the solution. Now, later on in the workshop, one of the last steps, we actually ask you to make your script generic, by meaning that you should be able to pass in a file name on the command line so that you can pass any number of FASTQ files to your script. And this is how we do that right here. So if we import sys, one of the field names in sys is argv, and the first item of argv is the name of the script, always. And the second item of argv on will be the command line arguments that you pass it. So here we are saying that the first command line argument after the script name should be the file name of the FASTQ file that we want to process. Now I'm going to skip down a ways first to introduce this line. So you'll notice that I'm using this counter class, which is from the collections module of the standard library. And all the counter class is basically a dictionary that stores numbers and allows you to count keys simply by adding numbers to them. And we'll see how I use that later. I'm going to skip down here and start talking about this. So with defines a context that we're going to use by opening a gzipped file. Now, the gzip module in the standard Python library allows you to operate directly on gzipped files. And so what we're doing here basically is we're saying gzip.open file name, because we know the file name is going to be a gzipped FASTQ file. And then this variable file pointer f operates like a normal file pointer. So we can iterate through it. We can read from it, read lines from it, and so on. Now, what I wanted to do is just to make this Pythonic and readable, I created what's called a FastQ iter. So a FastQ iterator, as I define up here, is essentially a function that a for loop knows how to iterate through. Now, remember that FastQ files have 4 lines. And so all this FastQ iter does first is that it iterates through this file pointer that I pass into it. And H here is the header. So the first for loop iteration, only the first line is read, which as we know in a FastQ format is a header. Because we're opening up a gzip file, these header, whatever we read out of H is actually a bytes object. So we want to decode that to a UTF and turn it into a string. So that's why we're doing this. But then, so far, we've only read the header. And we want to read the following 3 lines, which then completes the FastQ read. And I'm doing that by using what's called a list comprehension. So in this list comprehension, it's basically like a for loop on one line. And so you can see for underscore, this underscore doesn't really mean anything, in range 3. So we're iterating 3 times. We call next on the same file pointer that we're iterating through, and also turn that into a string. Now this is perfectly legal. You can call next and advance a file pointer line like this inside the body of a loop if you know, as in our example, that you want to call next a fixed number of times during iteration. So now we've read a header, we've read the sequence, we've read the quality header and the quality. And then finally we have this yield statement. Now a yield statement is kind of like a return statement, except that a yield statement doesn't return from the whole function. Once a yield statement is reached and it is being iterated through, as we are down here in this for loop, then execution continues, and this for loop iterates again, but then it waits, execution waits at this next yield until the next iteration in this calling context. Now, the last thing about this FastQ iter is this FastQ read thing that I created here. And what this actually is something called a named tuple, which is in the Python standard library or collections module. And all named tuples is they're tuples that, surprise, have names associated with their fields. This is mostly used for both efficiency and for readability. And so basically the way that we call this here, this named tuple, the first argument is a name that we want to give, say the class of the tuple, and then the second argument is the name of the fields of that tuple. So this FastQ iter, whenever it yields an item, it's yielding a FastQ read type that has the header, the sequence, the header, the quality header, and the quality. Now, if we go back down to our for loop, where we're reading through our FastQ file, so we're iterating through our FastQ, and every item that is iterated out of this iterator is in this read variable. And you notice below, I say if read.seek, meaning that read is some object that has a sequence field on it. It just makes this code much easier to read and actually more efficient. So that's all this named tuple thing is doing. Now there's 2 other things that this for loop is doing. One is I'm using a set, because remember, one thing that we want to do is we want to deduplicate these reads and retain only the unique sequences. And then also, remember I initialized these, there's this counts object, in which I'm saying, okay, total, this total key is incremented for every read that we have read in. So this total will be the total number of reads. And then since we have read.seek, and read.seek is a string, we can say ends with caca, if read.seek ends with caca, add that sequence to our deduplicated read set, and increment caca. And that's it for this one, to be continued in part 2.